Let's just jump right in with the fundamental problem of our time. We are surrounded by this explosion of computational power. It's getting faster every single day, but all of it, every last bit of it, lacks one absolutely critical component: real, genuine intent. I mean, these systems can mimic us, they can predict what we're going to say next, but they can't originate anything. They are, for all intents and purposes, philosophical zombies.
So today, we are going to unpack a technical proposal that is, well, it's nothing short of radical. It completely redefines the relationship between humans and machines. And no, we are not talking about another fancy chatbot. What we're looking at here is a blueprint for an entirely new architecture of agency. A system that's designed to amplify human cognition, not replace it. Let's dive in.
All right, here's our roadmap. First, we're going to tackle this core idea, this paradox between intelligence and agency. Then, we'll go deep, and I mean deep, into this new hybrid architecture. We'll look at this ingenious chemical gate, a mind-bending computer that runs at the speed of light, and something called a synthetic intuition loop. And finally, we'll look at the big picture, the strategic plan that could make all this science fiction a reality.
So what is this paradox all about? Well, it's actually pretty simple when you think about it. On one side, you've got AI systems with just unbelievable processing power, but they have zero, and I mean zero, actual agency. And on the other side, you've got us, humans, with this deep, profound, genuine agency, but we're stuck. We're trapped trying to communicate with the world through these tiny, low-bandwidth interfaces like keyboards and microphones.
And that brings us right back to this idea of the P-zombie. Think about today's large language models. They are absolute masters of mimicry. They can write you an email that sounds perfectly human because they've crunched the numbers on trillions of examples of human language. But here's the thing, they don't mean a single word of it. There's no internal spark, no state of intent behind what they generate. They're just incredibly sophisticated simulators, not originators.
So if that's the problem, what's the solution? Well, the answer this proposal gives is it's so elegant. It says, don't try to build artificial agency from scratch. Instead, augment the real thing. And this is where the Neurophotonic Agent, or NPA, comes onto the scene. We're not talking about digitizing the brain anymore. This is about creating a true, seamless, biological, synthetic hybrid.
And you can really see the difference here. Traditional brain-computer interfaces, they're basically trying to build a faster typewriter for your brain. They take all of this incredibly rich, parallel activity happening in your mind, and they try to squeeze it one bit at a time through this slow digital bottleneck. The NPA just flips that whole idea on its head. It's not about translation, it's about expansion. It creates a parallel extension of the mind itself.
Okay, but this leads to a huge engineering challenge, right? I mean, the brain is electrically noisy. You've got billions of neurons firing all the time for everything. Background processes, stray thoughts. So how in the world do you isolate the actual signal of a deliberate, high-level thought from all of that background chatter?
The solution proposed here is just a brilliant piece of bioengineering. It's essentially a four-step chemical lock-and-key system. It all kicks off when a high-intent thought releases a little surge of a neurotransmitter called glutamate. Then an enzyme that's built right onto the device converts that glutamate into a tiny puff of hydrogen peroxide. Now that peroxide, that's the chemical key. It flips a switch, and in that instant, it transforms the brain's electrical signal into a single particle of light, a photon.
And this diagram really shows you how it all comes together. You can see the glutamate coming in at the top, the enzyme doing its work, and then that peroxide, the key, diffusing down to the switch layer. And here's the main takeaway. Random electrical noise from the brain? It doesn't have the chemical key, so the gate stays shut. Only a chemically validated signal of true agency gets to pass through. It's a completely noise-immune bridge between biology and optics.
Now, the secret sauce that makes this whole chemical gate possible is a breakthrough in materials science called defect-engineered ALD. So picture a protective coating, just nanometers thick, designed to be a perfect waterproof seal around the implant. But, and this is the clever part, it's built with intentional nanoscale defects. These defects create a mesh that's big enough for the hydrogen peroxide key to slip through, but way too small for water molecules. It turns a simple shield into an incredibly precise functional filter. So, the gate is open. A photon, born from a thought, is released. But where does it go? Well, it travels into the heart of the system, a completely new kind of computer, one that doesn't run on electricity, but on light itself. I want you to just look at that number for a second. 0. The core computation, the actual thinking part of this device, consumes 0 power. And this isn't just some cool efficiency metric. For a device that's implanted directly in the brain, generating no heat isn't just a nice feature, it's an absolute non-negotiable requirement for safety.
And the second benefit is, frankly, just as staggering. The processing happens in about 10 femtoseconds. That is a few quadrillionths of a second. How is that possible? Because the calculation is literally happening at the speed of light. That digital bottleneck we talked about earlier, it's not just been made wider. It has been completely and utterly eliminated.
So how does this light-speed computer even work? Well, this thing, the Dawn, it's nothing like a computer you've ever seen. There's no CPU, no RAM. It's basically a solid, transparent crystal. The software is physically 3D printed inside the crystal as layers of incredibly complex surfaces. So when that photon from the brain enters one side, it bounces and diffracts through all these layers, and the answer to the computation is simply where the light comes out on the other side. The calculation is the physics of light unfolding in real time.
All right, so we've covered how a thought gets out of the brain and gets processed at the speed of light. But that's really only half the story, isn't it? How does this system deliver its incredible insights back to the user, and not as text on a screen, but as a genuine thought?
This is the final, beautiful piece of the puzzle. The light coming out of that crystal, the answer, is focused onto a tiny photodetector. That detector instantly converts the light back into a very localized electrical field, which directly stimulates a specific target neuron. It completes the loop, from thought to light and right back to thought, all in an instant.
Now, critically, this is all done using a technique called capacitive coupling, and this is an absolute game changer for safety. The device never actually injects damaging electrical current into the brain. Instead, its electric field just kind of influences the neuron across a tiny insulated gap. It gently nudges it to fire, and because that signal completely bypasses your normal senses and triggers the neuron directly, the brain perceives it as an endogenous insight. It feels like an idea that came from you.
Okay, I know what you're thinking. This sounds like it's straight out of science fiction. But this proposal is actually grounded in a very real-world strategy. So how do you protect a technology this revolutionary? And maybe more importantly, who is going to fund it?
The intellectual property strategy here is built on 4 incredibly strong pillars. They're not just trying to patent a single gadget. They're claiming the entire biophotonic architecture, the specific chemical gating mechanism, the unique material composition that makes it all work, and even the method for getting brain tissue to integrate with the device. This creates a really formidable, defensible moat around the whole technology.
And here's the kicker. This isn't some solution looking for a problem. This project lines up perfectly with the stated high-priority research goals of agencies like DARPA, the NSF, and ARPA-H. Look at the keywords: hybrid intelligence, biological computing, semiconductor synthetic biology. These agencies are actively looking to fund exactly this kind of groundbreaking work. This proposal is a direct answer to their call.
And that really brings us to the core philosophy, the entire why behind this project. The goal here is a true paradigm shift. This is not about building an artificial mind that can compete with our own. It's about building a tool, a new kind of lens that augments and expands our own native human agency. And so that's really the question that a technology like this leaves us with. It completely reframes the whole debate about our future with AI. What if the path forward isn't about desperately trying to make machines more like us, but about giving ourselves the tools to become so much more than we already are? It's a really powerful idea to think about.